Good afternoon, everyone. My name is Prathamesh. In this talk, we are going to talk about uh, PostRAG. It's an architecture that we created based on our experiences in developing various LLM-powered conversational apps, which are essentially enterprise apps. And from there, we have collected knowledge and made up with this framework, which are like just sensible defaults for when you go about building any enterprise LLM apps. So what we are going to cover is we'll talk briefly about what are the various risks that when an enterprise wants to use Gen AI, especially LLM, what are the risks that they perceive, and then understanding how this architecture can help in reducing hallucinations and some of the other concerns. And we look at the architecture, understand some of the instances of this architecture. So that's what we are planning to cover. Okay, so with that, let's understand that now, like everyone here, I'm sure must have used ChatGPT, right? So that's very nice, right? It's very cool. It gets you off the ground very quickly. You can do things very, very nicely. But when you actually want to put it in production, uh, when you talk to any of customers, right, the first thing that they'll say is, "Hey, that's all is great, but does it work in production?" Right? So the first and the most things that they're concerned about is hallucinations. So raise of hand, how do any of you know this term, hallucinations? Uh, Quite a few actually. Yeah. So this is the biggest concern with using LLMs, especially that hallucination means that if you ask a query to ChatGPT, for example, it will give you an answer, right? And even if it doesn't know answer, it will make up an answer which could be many times wrong, right? And that's the real key that like that can be like for the production apps that can be a real danger. That means you can't rely on happy path scenarios, right? You need to understand that the information that is provided by my app is actually trustworthy and people can rely on it and take actions on it. So that's one concern. The other concerns that people typically flag is privacy concerns. That means whether some of you must have heard about the Samsung case that has happened, right? So the intention wasn't to leak out information. Actually the intention was to get a answer about something that, okay, what are others doing or what is happening, and to do that they shared some of their internal details which went to ChatGPT, and then they land up in the soup, right? So that can happen. At the same times, many of the financial institutions require that your data can't leave your org boundary, or many times like when we are dealing with governments, courts, they say that you can't leave certain geographical regions, right? So that's one of the risks. Other being ethical issues. That means like let's say I create a bot and then you do some kind of attacks in some ways, and then it starts giving me an answers which are not necessarily ethical. It puts your brand on line, right? That this is a app I'm using from certain company. So if it starts giving an answer which are not ethically correct, if they're biased, then your brand goes for a toss. So these are some of the top risks that people normally talk about. And in this architectural, so what we are going to talk about is how to handle some of these. It's not possible to completely eliminate this, but it's definitely possible to reduce this up to an extent as much as possible. So let's understand that how can we reduce hallucinations. Before we understand how to reduce it, first thing is to understand why do hallucinations happen, right? So when you ask a query to chat gpt, right, where does it get the answer from, right? You must have wondered. So the common answer is yes, it knows, it has crawled internet, right? It has access to all of that data, and it will just do a search and then coming all of that information is stored in the billions of parameters that are there. So that's one source of knowledge that we are calling as a parametric knowledge, right? And it's very hard to for as a user to control what it has scrolled, right? Obviously there are cutoffs, etc. But as a user you can't do anything about it, right? Whatever it's there, it's there. And there is also the other knowledge source which people don't perceive as a knowledge source, but it's very critical to see it as a knowledge source. That is the prompt. People think that the input prompts are the only the questions that you ask, but that's not the case, or the instructions that you give, that what do you want to do. But that's not the case. Input prompt is a rich source of knowledge wherein you can pass in the information that you believe is the right, like contains the right answer to the user query, and then LLMs can then synthesize all of that information and come up with a nice answer in a way that a normal person can understand. So that's really important thing to understand. The second knowledge source is actually holding the key in all of this architecture that we are going to talk, right? And the final response that comes out of from LLM is typically a combination of it has learned from its parametric knowledge and this prompt, whatever we have put in. Because it's like, you need to understand that both work in tandem. You can't isolate them, and it doesn't make sense to isolate them. Okay, now with that understanding, let's understand this central concept of retriever augmented generation. This is the most important concept. If you want to take away anything from this talk, forget my name, forget Aman's name. Remember these three words: retriever augmented generation. This holds the key to most of the things that are happening current in LLM powered things. So what is it, right? So it's essentially three words, right? Retriever, and then it's augmenting your generation of LLMs, right? So retrievers are not new. We have been using them all throughout of our lives. Google, all the search engines. They could be simple keyword-based searches. They could be semantic searches, more sophisticated, anything of your choice, right? But the essentially thing, the central concept is the based on a user query or the information that I'm trying to seek, I use a retriever which will fetch information from my knowledge sources, which is required to answer that particular query, right? It may not be like, it can be more than what is needed, but it should be important that it should be enough to answer the query. That's the central concept. Now, once you get this thing out, you enter this LLM prompt window. You see three windows here. One is the instructions, and then this retrieved information comes, and this query comes. And then a prompt will, like, you will compile all of this, put it in the system prompts. I'm sure some of you have used ChatGPT APIs, so you're aware about these terminologies: system prompts, user prompts. And then you pass this to LLM, and then it generates response, right? And you will ask, okay, this is common sense, right? It's nothing new. What's the big deal about this? But this thing is actually is the key to reduce hallucinations. This RAG is key to reduce hallucinations and generate trustworthy answers, right? So what we did was we took RAG and we added some sensible things that, or some layers that often get missed out. And then we created this PostRAG architecture, which is what you see on your screens. And the architecture essentially, why PostRAG is like, you have, obviously it's built on top of RAG, but there are also some more things. So that's why we are calling it the PostRAG architecture. And in this, you see that multiple layers here, 1, 2, 3, 4, 5, 6 layers here, and the data flows from essentially from left hand side to the right hand side. And so basically it starts with the user. The UI layer is responsible for engaging with user. It could be in form of WhatsApp, Telegram, web app, whatever you want, IVRS. Then the conversational handling layer comes into picture, wherein you do all the kind of things about speech to text, translation, back translation, all of this, right? Depending on the applications that you're wanting to build. Recent advances in AI, I'm sure you must have seen Alexa, etc., etc. That's very powerful, and all those things come into this layer. In the data, so the third thing is most important. That is the data acquisition planning, right? So what is a plan, right? To data, what is a data acquisition plan? So it's essentially that where do I get the data that is necessary to answer the next step, or to take the next step, or to answer the user's query, right? And this could be done in multiple ways, right? It could be done in form of simple finite state machines, wherein you design a user flow in form of finite states, that you move from one state to another and then another, right? So it's a more traditional way of doing it, slightly older, but it still works. But there's also now very powerful thing that has come, which is LM agents, which is really like powering all the, or at least the next big thing in AI, that is depending on, let's say I have an LLM and I give it 5 data sources, right? So let's say I ask it that, okay, what's temperature today, or will it rain today? Rather than looking at the internal parameters of the LLMs, it should call an API, let's say weather.com, and then get that answer, right? So it has that understanding that if you give it the knowledge or the data sources, it can automatically decide which knowledge source or the data source I need to query in order to come up with the answer. So that's really powerful. That's something that is, people are saying it's next closest things to AGI. And then also you can have custom rules, etc. So once that happens, you have LLM augmentation layer, wherein you actually, the plan that you have created in earlier step, you actually do that and you execute it. So for example, here, it's a very typical flow nowadays to get your unstructured documents, create embeddings out of them. That means like, one is keyword based search, right? But that loses the semantic or the meanings of the words. So what you do instead is you pass that through an embedding model. It's another AI model, like OpenAI also provides an embedding, and there are other many open source models. So you pass them through an embedding model, create a vector store, right? And then once you store text in form of numbers, you can always do a similarity search based on the queries, right? So it could be coming from there, it could be coming from your SQL database, right? It's a transaction. I want to know my purchase order history. What do I do? I create an SQL query out of it, right? So all those things will or can call an external API, etc. So this layer is actually responsible for generating that information, doing it. And then comes the data privacy layer, which is, I think, very important. People often miss out on this. In this layer, actually, we are doing all the masking of sensitive information, the things that, or the PII masking, or any sensitive information that can change from model to model. So we're masking this information so that it doesn't leave your org boundary, right? Because essentially the next is LLM, which could be cloud hosted. So sometimes it's important to mask this, right? And once this is done, then finally you have LLM layer wherein you're actually passing the conversation history and all of this data to the prompts. You get the response back, and then which is sent back to the conversational handling layer and back to the user. So this is essentially the architecture, and these are the various layers. And what we have done is, like, we have using this architecture, we have created multiple of solutions, and putting them together, we are calling them as Jugalbandi, right? And Jugalbandi is very powerful, and it's nothing short of a fairy tale for us, dev team, starting from like 3 devs team, starting something, we show it to Satya Nadella. Satya Nadella gets excited. He talks about it at World Economic Forum. When Sam Altman came to India, he also spoke to about it. We even showed another solution. So that's one thing, which is the government schemes bot thing. So then we also build the talk to your own documents, that upload your own documents, create a similar thing. Then that solution we developed. Then eventually we built a G20 bot app for this, which was shown to Bangladesh Prime Minister Sheikh Hasina, and she paid an interest, and she said that we definitely want something like this to be implemented in Bangladesh. So we, I mean, it's been nothing short of a fairy tale journey, and Aman will take over from here and walk you through that journey. Yeah.
Thank you, Prathamesh. Okay, Prathamesh already talked about the Jugalbandi scheme chatbot, welfare chatbot, the G20 chatbot, and all those things. They are fairy tale. We quickly come from nothing to this point, and we have developed a lot of things. Uh, let's quickly show you what's actually the chatbot is about. So we have prepared a small demo of the chatbot, which will quickly show you that what actually it's doing in a live mode, and you can see the video. Let's see.
मैं एक किसान हूँ और मैं बेरोजगार हूँ, क्या सरकार मेरी मदद कर सकती है? So here I've asked that I'm a farmer who is unemployed and whether the government can help me. I've recorded this audio and uploaded this to WhatsApp, which is then and the Hashini models are then transcribing it into Hindi text, which is then being translated to be sent to the GPT model, which makes sense of this information, bases the information on government schemes that has been fed into it, and provides a list of relevant schemes. I can see that there are 2 schemes and I can hear more about them or read it as well. I will choose to understand a bit more about the second scheme, which is the Krishi Clinic or Krishi Vyavsai Kendra Yojana. Over here, it gives some information on the benefits of this scheme. And I say, can I?
So you saw a quick demo of the Jugalbandi scheme chatbot. What we have done is we created a so let me go back. So what we've done here, so we created a small chatbot in which there were, in India there are like 22,000 schemes. There are a lot of schemes, and you can't know all of them by name. Not a one person at all. And suppose you are someone, you want to search for a scheme, you want to know about it. There's some centers, CSC centers, you have to go and ask them, but that is not possible for everyone. And there are very illiterate and some people who don't have the information or education to even ask some of the people to know that whether they are eligible for the schemes. So there we had the idea that we can create a chatbot using the DaVinci chat GPT or our LLMs, where they can just tell them that what is their problem, and it can give the list of the schemes that they can subscribe to. And later on you can see that we can check on the benefits, and there are further more things that we can do, such as checking the eligibility also. So there it will quickly check, ask you questions that whether you are eligible, what is your age, what is your profession, and on that basis and some other things, it will decide whether a particular person is eligible for that scheme or not. So that is a very powerful thing. And same thing we showed to Satya Nadella as well. And Satya Nadella talked about it at the Davos forum. Let's hear what he said. So
I'll give you another anecdote, which for me perhaps was the most revealing of what can happen. I was in India at the beginning of January, and I saw this demo class. In India, one of the things that's very exceptional that's happening is digital public goods that are getting built for identity, payment, many systems. And one of the digital public goods that's getting built is for language translation. Right? So basically they have an open source project so that anybody building any application in India can translate between any language in any Indian language. So a demo I saw was a rural Indian farmer trying to access some government program, right? So he just expressed a complex thought in speech in one of the local languages that got translated and interpreted by a bot, and a response came back saying, go to a portal and here is how you'll access the program. He said, look, I'm not going to go to the portal. I want you to do this for me. And it completed it. And the reason why it was able to complete it was because a developer building it had taken GPT and trained it over all of the Government of India documents and then scaffolded it with this speech recognition software. So think about what that meant, right? That basically meant that a large model, a foundational model that was developed in the West Coast of the United States a few months before, had made its way to a developer in India who then sort of added value to it to make a difference in a remote villager's life. And I've never seen that type of diffusion. To your point about the Industrial Revolution.
So we quickly heard about what Satya Nadella thinks about the Jugalbandi, and he found it fascinating completely, and he was surprised with it that what can be done, and just from the simple thing we can see that there can be n number of use cases. We can apply the similar kind of thing to n number of things, and it can be helpful to large amount of people. So how it's done? Prathamesh already talked about PostRAG architecture. We use the similar kind of architecture in the Jugalbandi chatbot as well, and let me quickly go over.
I'll give you another anecdote, which for me,
yeah. So we already Prathamesh talked about the PostRAG architecture. We use the similar kind of architecture. It's just a part. We use parts of it in the Jugalbandi chatbot because we don't need the whole architecture. So let me quickly go over it. So we have the same thing that we have the WhatsApp as a medium where the people are interacting. In this one, we are using Bhashni. So Bhashni is a government-backed language program where they are developing language models for ASR, translation, and speech-to-text. For all the Indian languages, there are 22 languages that we support right now. So we use those languages, those APIs to do our speech-to-text, translation, and everything. So Thoughtworks also helped in developing the initial models for them through the Vakyansh program, and that helped a lot. And that's how the Bhashni has came to this point, and there are now the recent models that are far much more better. So coming to the main point, so in the remember in the PostRAG architecture there were multiple things that we can do. There were agents, there were finite state machine, there can be third-party APIs. Here we use the finite state machine as our main thinking mechanism, which created the flows of the user. So how a user can interact, what kind of questions they can ask, how the schemes will go. If they ask for a problem, then what should be triggered. So we created a normal flows that search for a scheme, give them a relevant scheme, ask eligibility questions, give them the benefits. So this one is the just making the decisions. Based on the decisions, we have already scraped from the myschemes.gov.in. So this is a website by the government where all the schemes are listed. They are regularly populating new schemes as they come, and they are populating information about them. So we scraped the information from there and created the open AI embeddings and then scheme vectors. So Prathamesh talked about when you convert the text to numbers, it is far much more easier to do lots of different kind of things on that. We use the FAISS searching mechanism, which is very developed by the Meta, that can give you the nearest searches. It is like finding the similarity matches. So given a query, it will find out that which scheme can be helpful. And on that one, we do the further filtering that, okay, it gives us 10 schemes. Now, which 5 schemes can be important or which 2 schemes can be important. So based on that, we get the scheme information of those 2 schemes and the user's information that they have provided and do a PII masking on that, because sometimes people can provide Aadhaar card information, mobile number. Those we don't want to send to a third party application like a LLM. They are private information. Why should we send that? And later we have the conversation history as we saw in the PostRAG architecture, and then we use the Da Vinci model to generate our response. So it's just a scaffolding of the same PostRAG architecture with different elements, and we create the response that we saw. That you asked for a scheme that, and it give you two schemes. Then you selected a second scheme, and then it give you the benefits of that scheme. In the similar way, you can do the multiple things. Going ahead, so Prathamesh talked about the G20 bot. So recently, this is the new thing that we did. So there were some documents of the G20, and we came to know that there are delegates want to come, and they want to access the documents. Now, documents are big. We don't have time to read all of them, but we want the specific information, but it takes time to search for them. What we can do, so we created a generic Q&A API under Jugalbandi. So that can do in what we do is we upload some of the documents, and on those documents you can do the Q&A. Now it is a very simple thing. Upload a document and then make a chatbot out of it. That's what we T20 documents, and then on that one we created a chatbot. So let's quickly see that what actually it does, and then I will talk about it, that how we have done it and how it is different from the Jugalbandi scheme chatbot.
Hello everyone. In this video, we are going to see how G20 Jugalbandi bot works. So you can either talk to this or send text messages to this bot in multiple European languages, Indian languages, and get the response in your preferred language. So let me select English. So the bot introduces itself, says that I can talk about G20 summit that's happening in India this year, and you can ask it a question in voice, or you can type it in form of text. So let me send it a question. What are various tracks in G20? So this question is sent to the backend, and backend we have uploaded multiple of these documents that form the knowledge source about what is G20, and providing various information about G20. So once this information, the bot searches over an answer. So it says that now there are various tracks. So there are Sherpa track and finance tracks, and it gives the details. And it also gives you an answer about that in audio.
The various tracks in the G20 are the Sherpa track and the finance track.
Right. So it gives you the entire answer in audio. The other good thing about this question about something that is not related to G20, or about something that is related to G20 but not included in the knowledge source, then it will politely decline, saying that I don't know the answer. Let me ask it a question about the next IFA World Cup. So in this case, the answer is not present in the document, so it will politely say that I don't know the answer. So what's happening here in the backend is that we have used Jugalbandi APIs, wherein you can upload.
So we saw the G20 chatbot. You can see that this architecture is roughly similar to the one that you saw earlier. It is very same. There's not much different. That is the very good thing about the PostRAG architecture. You don't have to change a lot of things to make a something new thing. So here we have the same kind of thing. We are using Bhashni and Google as a speech services because we wanted to have some languages for the delegates too, like Russian, Japanese, and more other languages. So we have them doing our translation work, and we have the document too. We have uploaded them already. Now we have created the, as we said, that we created the OpenAI embedding and we created a vector store of it. So there we don't need any kind of finite machine or anything. We just do a search on it, and we get the relevant information piece. So suppose somebody asks that, Prathamesh has asked that what are the different tracks going on. So it can just search out the information where the tracks information is written, and then take out that part. And on that one, it will take it, send to the ChatGPT, and then it will generate a response. So that is a very quick thing. You don't have to read the whole document to know what other tracks are. It reduces your time. It's simple and it can be done. And the good thing about the RAG architecture, you can replace anything anywhere. So remember at the beginning of the slides, there was a one slide that the issues that we are facing. One of them is the hallucination, privacy. So how hallucinations are handled in the PostRAG architecture, you can see here. Remember, Prathamesh, at the end of the demo, he asked us some question which was not there in the document, and said that I don't know about it. Now, one thing you might have popped up in your mind, or I will pop it up. So, ChatGPT was trained way back. It doesn't know anything about G20, any event, what is happening, what is going to happen there. But how did it answer? That was where the things came in. We send the information in the prompts. That information from the document we send in the prompt. So that's how it came to know. That's why injecting information in the prompt is important. That's how it generated a response on the G20 question, and that's how it said that I don't know anything. So here we can see that we roughly reduced the hallucination completely. But there was a very less hallucination. We can say that there's none at all. It did not told you that FIFA is gonna happen in something 2026 where it doesn't know. It just told you that I don't know, and that's what we want. We don't want hallucinations. With the PIM asking, we can stop. We can handle the issues of privacy. We don't say anything. And at the PostRAG architecture, everything is pluggable. We can change from ChatGPT. We can so recently there are multiple open source models. Llama 2 is there. OpenChat is there. There are different. Falcon 180 billion has been released. Somebody can host their own LLM and they can quickly replace the ChatGPT with that one, and that's how you can have your internal LLM internal system with. Moving on. So what are the three risky areas? So as you said, and that's how we are dealing with them. So significantly reducing the hallucination by using trustworthy data and filtering the sensitive information for the privacy and ethically restricting the knowledge boundaries. We handle these kind of issues, and that's how the post is solving it. Now, we did everything in the OpenAI mission, and Prathamesh is going to talk about it.
Quickly, I'm aware about lack of time, but quickly talking about OpenAI, this all of us done as part of OpenAI, and people ask us, hey, what did Thoughtworks do? So we are the main tech partners in OpenAI mission. OpenAI mission is an open collaborative mission that is aimed at developing or using advances in AI to make access to justice more accessible in India. And we have been doing a lot of work in this, and I invite all of you to collaborate with us in terms of joining as OpenAI mission. Apart from Jugalbandi, we have been hosting a lot of other models we have developed, and we write research papers, etc. There are other tech partners that we regularly collaborate with: Quickstep, Agami, and Rohini Nilekani, Philanthropies, IITs, prestigious law schools of India. And we all of are coming together in this mission. So just wanted to say that. Maybe go to the next slide, Aman. So this is where so these are some of the repositories. All of the work that we do is open because we are open by design, by choice. And I invite all of you to try some of these repositories that are available. And this also is a QR code to the chatbot.
The G20 chatbot that you show in the demo. Yeah. So this is a QR code for the Telegram chatbot that you can try out if you want.
You open the floor now to questions. Thank you. Maybe start with maybe you can.
Yeah, open for questions now. So mics can please go to the people who raise their hands.
Maybe I don't know. Maybe just ask. I'll paraphrase the question. Yeah, please.
Yeah, we have the first question here from the.
Okay, she'll coordinate.
Sorry.
Hi, this is Jeffy. Being a solution architect, I think this amazes a lot. I think. So one of the important things I think just wanted to understand the governance around, right? So when you talk about amalgamating the data that you get from ChatGPT as a source and some internal source which you can specify. So what are the governance around it? Like how much do you take from ChatGPT? Are there principles, guidelines around it, around there? And when you talk about amalgamation of the data, right? There's a lot of system design aspect that comes in terms of the data. That how do you handle that, like in a real world scenario?
Yeah. Okay, because it's very hard to control ChatGPT's behavior. The only way you have is to write certain prompts that saying that okay, stick to the information that I've given, don't go outside this, and then here is the information. So eventually what happens is like the final synthesized answer will be paraphrased by ChatGPT, but it's using this information that I'm giving to you as input. So that way, that's the only way to play around. So with LLMs, that you design the right prompt saying that, okay, don't go outside this, stick to this information. If you don't know, just say, I don't know, etc. So these are the various ways in which the prompting help us to synthesize all of this together.
And when you talk about the ethical part of it, right?
Yeah.
So if I define what is ethical for me. I think,
Yeah.
is that something that can be amalgamated also as part of your response? Because I saw something when you say PHI masking and other things, but
Yeah.
as a part of your amalgamation, how do you define, okay, this is what is ethical for me in terms of the answers?
Yeah.
Right? Can we define that as well as part of the responses that we get in, and then feed that back to ChatGPT to answer it in a
Yeah.
defined way, maybe?
Right. So there, I think the formation of knowledge source is very important, right? Because it's going to use it. So if your questions are going to be answered very clearly in the authentic or the trustworthy documentation, you can rely more on that in saying that, hey, don't paraphrase and don't go too much, and you can adjust some of the parameters of LLM like temperature, that don't change too much of it. Maybe just you reuse most of what is written, right? It's just that some things need to be paraphrased, but yeah. So that's the thing, right? You need to have the right information in your eliminated, and that's where the testing becomes very important.
Okay. And one last, sorry, I'm taking a lot of time, but just one, a lot of LLM is coming up, right? Is specific to the domains, and do you see a lot of crisscrossing of the data and then working together of the data of different LLMs to get the rightful answer?
I mean, that's all possible, right? It's definitely possible to use, ask the same question to multiple LLMs and then synthesize them together again using an LLM. That's also plausible approach. I mean, it completely makes it, just makes it more expensive and slower to do all this.
Thank you.
Multiple chaining. Yeah. Maybe we have time.
Yeah, we can take two more questions.
Yeah, two more questions. Okay.
First, I would like to appreciate the work you guys done. It's a phenomenal job. And I have a question on this. You mentioned in the presentation that you have 6 layers, right? So among these 6 layers, can I plug and play with our own models? For example, in the case of the second layer, you mentioned bossing.
Yeah.
So can I replace that with Whisper or some
absolutely.
Google models?
Absolutely.
All the 6 layers are flexible enough to
Yes,
replace?
it's a reference architecture. Implementation is yours. So
Awesome.
you can make your choices.
Thank you. And the final question is on the data acquisition part. In the case of Jugalbandi, what is the relevance of data acquisition? Are you guys making any API calls to the third-party services?
Currently not, because we ask people to put trustworthy information, and API calls, while it's easily plug and play, because with agents, right, you can easily call APIs on the fly, and you can just give access to an API and just say that, okay, this is available whenever a user is needing this information, ask it. So that's very well possible out of the box. But for this, the 2-3 implementations that have been done, we didn't need this. So we haven't incorporated.
In the case of PIA masking, personal data masking, are you building any engine or is it a rule driven?
No, so currently it was rule driven, but there are many, as I said, like AWS has Comprehend, AWS Comprehend. There are many other things that are coming up now. You can use any of the open source things. You can use rule matching, depending on the level of sophistication that is needed. Because what is PI for me might not be PI for you. So that's the
awesome, great. Thank you.
One last question, please.
Hey, hi. Thank you for the nice presentation. My name is Abdul. So one problem that we are facing right now when we have ChatGPT based applications fraud is the feedback loop for the user, right? And you have shown the bot, but maybe I missed, but I didn't see in case they liked it, they found it to be the actual answer that they're expecting, or it was not the case.
Right.
So what we have faced is there are situation out of 1,000 prompts or 1,000 inputs, 1 or 2 are where they didn't like it. And we go and revisit and probably try to retune or whatever, change the prompts. So did you face that problem? Because I don't see feedback.
Yeah. In this architecture, there was no feedback. But yes, essentially, when you put it, I think, yes, this is another implicitly, it was there in our bot. You can do thumbs up or thumbs down. But I think the more formal way to do this would be to put it in the loop itself, like put it in the reinforcement learning loop, this feedback. But it's like a slightly complicated, and you need a controlled user base. When you generate it or when you crowdsource it directly from your users, the way to handle that feedback is different than what you have over a controlled small team. So with the small team, you can directly put it in the loop in the reinforcement learning. With this, you'll have to manually kind of just look at it, where are the issues, and then maybe see how can you go about doing it better.
Thanks a lot. Thank you.